Hello everyone and welcome back to Easy Dentistry, a channel that makes dental education easy and interesting. Today we are going to study Polycarboxylate cement. This is the sixth part of our lecture series on dental cements. Watch the first 5 parts in our playlist. But before we start, please subscribe to our channel and hit on the bell icon so that whenever we upload a new lecture, you get a notification of it. Also friends, please go to our channel page and go to the option playlist. There we have uploaded playlists on different dental subjects like dental histology, dental anatomy, dental materials, microbiology. You can go to that subject playlist and play all your favorite lectures. All the lectures are given in sequence in our playlist. For example, when you go for our channel page of Easy Dentistry by Dr. Pranali Satpute and select the playlist option, and if you want to study the topic dental amalgam, go to the playlist of dental materials. There you can find all the parts of dental amalgam topic like part 1, part 2, part 3 and part 4 in sequence. So you will not miss any part. Now let's start with today's topic, that is the zinc polycarboxylate cement. In this lecture we will be studying the introduction, applications, mode of supply and composition of zinc polycarboxylate cement. Also, we would be studying about how it is manufactured, what is the setting reaction, what is the structure of the said cement, the properties of zinc polycarboxylate cement, and how it is manipulated. So, starting with the introduction to the zinc polycarboxylate cement, it is the first cement which has been developed that adhere to the tooth structure. So, this is an important MCQ question. It is the first cement which is developed which adheres to the tooth structure, the zinc polycarboxylate cement. Now the applications of zinc polycarboxylate cement, it is used for luting. Suppose this is the prepared tooth and this is a prosthesis which is prepared on this tooth. So when we want to lute this prosthesis on this tooth, this can be done with the help of the zinc polycarboxylate cement. Also, it can be used as bases and liners in cavity. If the cavity is prepared, then it is lined with a base or a lining of zinc polycarboxylate cement. Then it is used for cementation of orthodontic bands. Suppose this is an orthodontic band and if you want to cement this on this tooth, then you can use the zinc polycarboxylate cement to lute this band on the tooth. And it also can be used as a root canal filling material. So these are the applications of the zinc polycarboxylate cement. Now the mode of supply, how it is supplied. It is supplied as powder and liquid in bottles, also supplied as water settable cements, and also in the form of pre-proportioned capsules. Now the composition of zinc polycarboxylate cement. The powder of zinc polycarboxylate cement consists of zinc oxide, which is the principal ingredient, then magnesium oxide, which acts as a modifier and aids in sintering process, then bismuth oxide, and aluminium oxide is available in small amount, and stannous fluoride is present, which increases the strength, it modifies the setting time, and it shows the anti-karyogenic property. Now the liquid is a solution of polyacrylic acid or a copolymer of polyacrylic acid, itaconic acid, malic acid and tricarbalic acid. Now what are the water settable cements? These are the cements which are available as powder. This powder contains the freeze-dried polyacrylic acid. Now, when this powder is mixed with water, the reaction proceeds. So, these are called as water settable cements because they set with water. Now, let us see how the polycarboxylate cement is manufactured. It is manufactured by the process of sintering. All the components of the powder are heated at a high temperature and then it is ground into fine particles. So this is how the powder is produced. Now the setting reaction of polycarboxylate cement. When the liquid is mixed with the powder, zinc, magnesium and tin ions are released from these powder particles, and further the setting reaction occurs with the help of cross-linked salts. Now, how is the structure of set cement? The set polycarboxylate cement consists of unreacted powder particles in an amorphous gel of zinc polyacrylate. The setting time is about 7 to 9 minutes. This setting time can be increased by cooling the glass slab, and it also depends upon the method by which the powder and liquid are manufactured. Now the properties of the cement. The mechanical properties, the compressive strength of polycarboxylate cement is 55 MPa, which is more than the zinc phosphate cement, which is less, than the zinc phosphate cement, and the tensile strength is 6.2 MPa, which is a little higher than the zinc zinc phosphate cement. Now the strength depends upon the powder liquid ratio. The higher the powder liquid ratio, the more is the strength. Also, the molecular weight of polyacrylic acid determines the strength of the product, and the viscosity of liquid. Low viscosity liquid gives weaker product, while the high viscosity liquid gives stronger product. Now, the second property, the solubility and disintegration. The solubility is 0.06%, which is more than that of the zinc phosphate cement. So this increased solubility results in marginal disintegration. Now the biocompatibility. The pH of the liquid of the zinc polycarboxylate cement is 1 to 1.7. The freshly mixed cement has a pH of 3 to 4, and after 24 hours this pH reaches up to 5 to 6. So there is decrease in the irritation of the pulp shown by polycarboxylate cement. The reasons for this reduced reactivity or irritation to the pulp is because the liquid is neutralized by the powder very rapidly, and thus the pH rises rapidly. Also, the polyacrylic acid have increased molecular weight and larger molecules. This larger molecular weight and molecular size decreases the penetration into the dentinal tubules. So less irritation occurs in the pulp. Also, the histological reaction is of the polycarboxylate cement is similar to zinc oxide eugenol cement, but there is more reparative dentine formation. Keep it in mind, in polycarboxylate cement there is more reparative dentine formation in the tooth. Now the fourth property is that of adhesion. There is a chemical bond between the cement and the tooth. This chemical bond occurs between the carboxyl group of the polymer group and the calcium present in the tooth structure. The bond strength. The bond strength in enamel is 3.4 to 13.1 MPa, while in dentine it is just 2.07 MPa. This is because of the high inorganic content of the enamel. Now the factors affecting adhesion. Firstly, meticulously clean and dry surface is required when using polycarboxylate cement. Presence of any saliva decreases the strength of adhesion. Also, adhesion on the smooth surface is more than that of the rough surface. So the cavity preparation should be very much finished. Also, the zinc polycarboxylate cement do not adhere to gold and porcelain. There is excellent adhesion to stainless steel, so it is used in orthodontics for the adhesion of the brackets and bands on the tooth. Also, the optical property, it is very opaque because of large quantity of unreacted zinc oxide present in it. And the thermal properties, it acts as a good thermal insulator. Now, talking about the manipulation of the zinc polycarboxylate cement. First, the tooth preparation. It should be meticulously clean. This cleaning procedure can be done by rinsing the tooth with 10% polyacrylic acid, followed by a wash with either water or 1 to 3% hydrogen peroxide. After that, the tooth is dried and isolated. Now, the proportioning of the zinc polycarboxylate cement. 1.5 parts of powder is used for every 1 part of liquid by weight. You should use a cool glass slab while manipulating. The powder should be also cool, but the liquid is not cool because cooling of the liquid increases the viscosity of the liquid. Now, on a cool glass slab, this is a cool glass slab, powder and liquid are taken in proportion. 90% of the powder is incorporated into this liquid and the remaining 10% of the powder is then mixed up and the consistency of the mix is adjusted. The mixing time takes 30 to 40 seconds. The mix appears thick but it thins out when pressure is applied to it while condensing into the cavity. The ideal mix is glossy. Loss of luster results in setting maybe due to the setting reaction which is advanced. So if you see a loss of luster, it means that the setting reaction has progressed and the mix is not ready for use. The cleaning of instruments should be done with alcohol and the cleaning should be done before setting. The boiling of the instruments in sodium hydroxide also removes the cement from the instruments. So here we complete the discussion on zinc polycarboxylate cement. The next lecture will be on zinc silicophosphate cement, copper cement and the resin cement. That's all for now. Please subscribe to our channel right now if you have not yet done, and happy studying.